Welcome students, let us see this question. This question says explain why the long-term probabilities for this graph will not be independent of the starting position. So we have a directed graph and we have to explain why the long-term probabilities of this graph is not independent of the starting position. This is obvious because as you can see there are two states in this graph which are purely absorbing state, right? What is the meaning of in purely absorbing state? That you can only arrive on that vertex. See, there are two states A and E. On that you can only arrive, you cannot go from vertex A and vertex E. So the reason for or the explanation for the first part is two absorbing state. So we can write two absorbing state in this graph. So we can also name them, so that are A and E. So due to this its long term probability will not be independent of the starting position. Let us see the next part, that is the part B. Write down the probability that a random walk would end at vertex A if it begins at vertex B. So we have to write the probability when it starts from B and ends at A. So for this we should write its transition matrix, then we should find its higher power, then we will see what's the probability from B to A. So first of all I am going to write its transition matrix. So it should be it should have six vertices, so A, B, C, D, E and F, and similarly A, B, C, D, E and F. So make a matrix arrangement. This will be a 6 cross 6 6 by 6 matrix, and this is a transition matrix. Its direction is opposite to the adjacency matrix. So from A to A, from A to A its probability will be 1. Why? Because it's a pure absorbing state, right? So rest all other, see, A to B, what's the probability for A to B? 0. There is no any path from A to B. There is no any path from A to C. 0. There is no any path from A to D. 0. There is no any path from A to E. 0. There is no any path from A to F. So all entries will be 0. The next one, B to A. Is there any path from B to A? Yes. See, for if, see, how many paths are out, getting out from B? How many paths are getting out from B? One path and two paths. There are two paths which is going outside from B. So the probability will be equally half, 1 by 2 and 1 by 2. So from B to A, if we go from B to A, its probability will be 1 by 2. B to B it's 0 because it's not a absorbing state, right? B to C, is there any path from B to C? No. B to D? No. B to E? No. B to F? Yes, it's a B to F, 1 by 2. So its probability will be 1 by 2. Next, similarly think C to A. Is there any path from C to A? No. C to B? Okay. How many paths are getting out from C? 1, 2 and 3. So each will have probability 1 by 3. C to A? No. C to B? Yes, so it should be 1 by 3. C to C? No. C to D? Because it's not a absorbing state, right? C to D? C to D? Yes, so 1 by 3. C to E? No. C to F? Yes, it's 1 by 3. As you can see, C to F, it's a path, it has a path, right? D. D, how many paths out from D? 1 and 2 and 3. So it will also have a probability 1 by 3. D to A? No. D to B? No. D to C? Yes, D to C. So it will be 1 by 3. D to D? No. D to E? Yes, 1 by 3. D to F? Yes, it's 1 by 3. E. E to A? No. E to B? E to B? No. E to C? Yes. No, no, it's a also E is a basically absorbing state. So no, no, yes, no. Next F, how many paths are out from F? One. There is one path from F. So uh, let us see. F to A, no. F to B, yes. F to B, there is a only one path, so its probability will be completely 1 and rest other will be 0. So this is the transition matrix. Now write down the probability that a random walk would end at vertex A if it begins at vertex B. So what we have to do, see, this is our transition matrix. So now we use our calculator and we will try to find its higher power. Let us suppose I have stored this transition matrix in my calculator as a matrix B, right? I have stored this, I will show you. So I will find its higher power also, then we will see. Okay, let us see. First of all, I will go to run matrix, then I will show you. I have entered my matrix already, so it's matrix, so it is in matrix B. I will show you all the entries are according to transition matrix, which I have already discussed and already written on the whiteboard. So this is the matrix, which is your transition matrix. What we have to do, we have to find its higher power. So see, first exit from this. See, I have already find it this matrix B raised to power 30. Okay, for your knowledge, your uh, satisfaction, I calculate it once again. Shift matrix, then B, this is my matrix B, and then raised to power 30, then execute. See, so now this is our higher power of this transition matrix. We have to find what's the probability that if I have started from node B, vertex B, and ends at vertex A. So that's the entry this. Second, that is the vertex B and ends at vertex A. So what's the probability? 0.9999. So what does it mean? It's 1. We can say this 1, 0.9999. So yes, this is a probability equals to 1. So the B part answer will be 1. Its probability will be 1, right? If x is the number of steps it would take for the walk to reach A from B, find E of x, expectation of x. This is a very conceptual question. See, what is my x? X is my random variable and it is the number of steps, it is number of steps that is taken to reach A from B. So first of all, we will try to find what are the possible values of x. X can take what values? Okay, so number of steps to reach A from B. Okay, let us see. Number of steps to reach A from B. Its answer was 1. See, so the first way it can take either one step B to A. The second step may be, see, one step B to F. Let me write B to F, then F to B, then A. So 1, 2 and 3. So 3 steps. See, 1, 2 and then 3. So we have two options, either one step directly B to A, or we have 3 walks, 3 steps B to F, then F to B, then A. So I think there are only 2 ways in which we can move from B to A. You can see there is no other way. See, you cannot go from B to C. I have already discuss this B to F. After getting F, after reaching at F, we cannot go to D, we cannot go to C. So I have only one option, that I can go to B, and from B I have to go to A. So there is only two options. One has one path, one step, and the second one has three path, three steps. So it can have either one value or three values. We have to find the probability of px. So this will be, see how we can find px is equals to 1. We can find it, see, we have to go from B to A in one step. We have to go from B to A in one step. So this will be given by our this will be given by the probability of transition matrix itself, because this is a transition matrix I have stored in my matrix B. So this is the power 1, so B raised to power 1, the it means the transition matrix itself will give this probability. So we have to go from B to A, so the probability will be 1 by 2. So it should have, the probability 1 by 2. So its probability will be 1 by 2. Next, when we have to go with three step, right, when we have to go in three step from B to A, so it will be given by the transition matrix raised to power 3. If B is my transition matrix, so first of all we have to find its third power. So let us see its third power. See, I have already find it here. It's a matrix B raised to power 3. So from B to A, the probability of going from B to A is 0.75. So we have to substitute this value 0.75, and now we can find its expectation E of x. E of x is equals to summation xi into pxi. So we have to multiply these two and add them. So this should be 1 into 1 by 2 plus 3 into 0.75. So what it should be? It should be 1 by 2 plus 9 by 2. So this will be, sorry, this should be, see, this will be 3 into 3 by 4. It should be 9 by 4. So it will be 1 by 2 plus 9 by 4. So it will be 1 by 2 plus 2.5. So this will be 3. So expectation is 3. Sorry. So this completed our third part. Let us see its fourth part. Find the transition matrix for the graph. We have already discussed. This is the transition matrix for this graph. Next, by evaluating higher power of the transition matrix, find the long-term probability of being at vertex E if you begin at vertex C. So we have to go from C to E in the long term. So let us see C to E. So we will go to the our calculator. B to E. See, I have already find its higher power of transition matrix. We have to analyze the result. So this is the result. So we have to go from C to E. Let us see C to E. Yes. So C to E. See, it's third C to E. This C to E, it means fifth vertex. C, third column, to E, it means fifth row. So its probability is 0.125. As you can see, its probability is 0.125. So its answer should be 0.125, the answer of E part. So students, I hope you have understood this question. So if you like this solution, please like this video and subscribe this channel for such more questions related to IB mathematics. Thank you. Thanks for watching.